Okay, so for week one, we're mostly talking about the order of operations and then going through arithmetic, which is adding, subtracting, multiplying, dividing, things with fractions. There's going to be some stuff on exponents, square roots, and then absolute values. And so this is going to be a quicker lesson because absolute values aren't too complicated, but this is a topic that for the quiz for this week, a lot of people tend to get wrong. They tend to mess this up. And so I thought this would be a good thing to do a video on. So the absolute value of a number, and we're going to use the letter A just to represent that number, could be any number. So you just in your head, replace A with a number. The absolute value, which we denote with these vertical bars. So you've got straight bars on either side of the number. Those are called vertical bars. It is the distance between that number and zero on a number line. So it's just how far away from zero is it? So if I've got a number line here, and I have 0, and let's say I am looking for the absolute value of 2. That is how far away from 0 is 2. And that distance is 2. It's 2 away from 0. So it's basically like the number. Now, if we were looking in the opposite direction, let's say we're looking at a negative number. And if I can get my pen to right. Okay. Let's say we wanted to know the absolute value of -1. So -1 is 1 away from 0. It's just in the other direction. So the absolute value of -1 is equal to 1. So distance is always a positive value. So when it's asking for the distance, it's basically saying whatever this number is, because every number is compared from 0, make it positive. So the absolute value makes things positive. Now, when you're writing absolute value on paper, I try to make my vertical bars taller than my number ones so that it doesn't look like the number 1. You want to make sure that when you're writing things by hand, you don't get confused, because I've seen people think their absolute value is a 1, or they think their absolute value is a parenthesis, which is different. That's curved. So you want to be very careful about how you write your work. Make sure it's neat and that you can tell the difference between your different symbols so that you don't get confused. Now, when you're trying to do absolute values using a keyboard, like let's say you're trying to type absolute values into Connect Math, there is a vertical bar on the keyboard. It's actually right underneath the backspace button with the backslash. And so you hit Shift and then you hit that key, and then that will get you your vertical bar. So the basic everyday definition is that absolute value is the positive version of whatever you're taking the absolute value is. It makes things positive. The technical math definition actually is slightly different. So if you have a number and it's non-negative, meaning that it's equal to 0 or it's a positive number, then the absolute value is that same number. It isn't changed. If your number is negative, so it's less than 0, then when you take the absolute value, in the math definition, you see it equals -a. Negative means the opposite. So it's just saying take the opposite of the sign. So when you have a negative inside your absolute value, the absolute value will take the opposite, making it positive. So the math definition is doing the same thing. It makes numbers positive. It's just written very differently. And so one of the things when you're taking algebra is trying to learn, how do I take this math definition? What does this mean in everyday words? The math definition is important when you get to college algebra, if you have to go on and take that class, because you are solving equations involving absolute values, and they use specifically that math definition versus the everyday definition that we have. So the key, that everything that you need to know for this class is what's inside the absolute value gets positive. So just have several examples here to kind of demonstrate these. And these are the type of problems where you can do it in your head. So there's no work to really show. So if you are taking the quiz and you're doing an absolute value problem, there's really no work associated with it. So it's just right or wrong because there's just, there isn't really anything to write down. So working from left to right, we have the absolute value of -7. So think of the absolute value of what makes it inside, makes it positive. So when you take the absolute value, the action of doing the absolute values disappear, and then you give your resulting number. So this will be 7. So those absolute values are an action that you take. You make the inside positive, and then the absolute value symbols disappear, and that's your final answer. The next one over, we have a negative on the outside of the absolute values and on the inside. So when you've got multiple negatives like this, the one thing is you cannot multiply a negative on the outside to the inside of an absolute value. They do not multiply through like that. So the order of operations, we abbreviate with PEMDAS. So parentheses, exponents, multiplication and division, addition and subtraction. Absolute values fall under the kind of the parentheses step. Even though they are not parentheses, that P is kind of things that are grouping things together. So absolute values are done first. So that negative on the outside of the absolute value, if you were to try to take that negative and then say, oh, 2 negatives make a positive, that would be multiplication. But multiplication is after you do the absolute value. So you have to actually do the absolute value first, then deal with the negative on the outside. So the absolute value of -3.7, that is a positive 3.7. It makes whatever that thing is positive. But we've got a negative on the outside of this. So we end up with a negative on the outside of our answer, our final answer. So the final answer to negative absolute value of -3.7 is a -3.7 because the absolute value first makes it positive, then we have another negative on the outside that makes it negative again. So this is one that a lot of people mess up. They want to make it positive, but it actually results in negative because you have to do it in a specific order. There are questions on that one because that's one where people usually, there might be questions. Next one, absolute value of 2. Well, if you don't see, if it's just a positive number inside the absolute value, when you take the absolute value, it stays positive. So that answer is 2. It's like easy. You don't have to kind of worry about any of these things. And then the last one, we have a negative outside absolute value of 2.5. There's not a negative on the inside. And this is the same thing. You need to do it in the order absolute value first, then deal with that negative on the outside. So the absolute value of 2.5 would just give us 2.5. But because we have that negative in the front, our final answer ends up as negative. So just like the negative absolute value, -3.7, both of those ended up negative because the negative is on the outside. Whether it's a negative inside the absolute value doesn't matter because when you take the absolute value, that negative disappears. So your sign of your absolute value answer depends on what the sign is in front of your absolute value symbol. So you can see that the 2 where we didn't have a negative in front of the absolute value symbols were positive when we took the absolute value. The 2 with the negative in front of the absolute value, those gave us negative results because that negative out after we did the absolute value kind of stays there. So here we are going to be kind of thinking about absolute values and then trying to determine, like, these are basically comparing different distances between numbers to see which one is farther away from zero or closer to the zero. This is really testing how well you understand the absolute value concept as well as these symbols. So these symbols, we've got inequality symbols and equality symbols. And the one thing that you need to know about math is that every little detail matters. The direction of the symbol matters. Every little bit means something different. I've seen a lot of people say, well, it's the same thing, but the symbols are not looking exactly the same. And so they are not the same thing. It kind of reminds me of the Chinese language and how they have different characters. Every little line on that character means something different and makes the character mean something different. Math is very similar with that amount of detail, that you really need to pay attention to every symbol and what it means and know the differences between different symbols because it matters. So for these problems, we just want to determine if the statements are true or false. And in order to do that, we want to first figure out what is the number after we take the absolute value, and then kind of read the inequality and determine is that true or not. And we always read inequalities from left to right. So first example on the left, I have the absolute value of -2 is greater than or equal to the absolute value of -1. So we're going to take the absolute value, and this would be equivalent to saying is 2 greater than or equal to 1, because those absolute values make these things positive. So 2 is greater than 1. And then that or equal to means it could be greater or it could be the same. So either one is true. As long as one of those is true, then this is a true statement. So because 2 is greater than 1, this is true. And so the absolute value of -2 is greater than or equal to the absolute value of -1. Next one over, moving to the right, we have the absolute value of 3 is less than or equal to the absolute value of -1. So when we take the absolute values, this would be 3 less than or equal to 1. So you kind of read it in two parts. It's 3 less than 1, which is false. 3 is bigger than 1. Whereas 3 equal to 1, that is also false. So both of those things are not true, which means that this is a false statement. So the original statement, the absolute value of 3 less than or equal to the absolute value of -1 is false. Next, we have the absolute value of -1/9 equal the absolute value of 1/9. So absolute value makes things positive. Whatever's inside is positive. So that's going to give us 1/9 on the left. And then we have 1/9 on the right. When we take that absolute value, those negatives disappear. Now we have 1/9 equals 1/9. Well, that is true. That, yes, there's the same thing on both sides. So that means the original absolute value of -1/9 equal absolute value of 1/9 is true. Next, we have the absolute value of 7 is not equal to the absolute value of -7. So it's just like the one we just did. It's just now we're looking, are these not equal? Well, when you take the absolute value of 7, or the absolute value of 7 gives you 7, and then the absolute value of -7 gives you 7. So this is a false statement. 7 not equal to 7. That's not true. 7 is equal to 7. So this is false. which makes sense because if it was equal to and that was true, then obviously the not equal to would be false because they give you the same thing out, whether it's a negative or a positive in. Okay. You re-explain why everything that is negative inside the absolute value comes out as positive. So let's go back to the definition. The absolute value.
I have a question.
Okay. Well, I'll answer the one that I got in the chat first. So we've got the absolute value is the distance between a number and 0 on the number line. Distance is always positive. If you were to tell someone how far away are you from this, from some location that you have to drive to, you would never give a negative answer. You would never say, I'm negative 12 miles away. You would be like 12 miles away. Distance is just always given as positive numbers. And that's what the absolute value is. It's defined as the distance the number is from 0. And so for negative numbers, it's to the left of 0, that distance is still going to be a positive number. You just count how many tick marks it is from 0. And then things on the right side, it's still, you count how many tick marks away from 0 it is. So either way, when you're counting how many of something there is here, it's going to be positive. So that is why everything inside the absolute value becomes positive when you take the action of doing the absolute value. So yes, when the absolute value is being used, what is inside becomes positive. It just makes things positive. I'm glad that the miles helped you visualize it. Yeah, that's thinking about it as like everyday terms. Yeah, it's just one of those things. Distance is always positive, and time, we always refer to time as positive. We don't say negative 2 hours ago, we would say 2 hours ago. So time is another one where you're always giving a positive value, even if it was in the past. So time is almost like it's always, very similar example with the absolute value. Okay. And I don't have an example of this specifically, but just as a side note, it's something that I cover and I have a video on order of operations. But if you see something inside, let's just get a little more complicated here. And let's say I have an absolute value of like -2 + 1. When you have more than one thing inside an absolute value, you need to actually simplify inside and get a single number first before you do the absolute value. Because the absolute value only works on a single number. It doesn't work if you have more than one thing inside there. Because then it's like, well, how do you make, like if you have a subtraction sign, how do you make a subtraction positive? Like it doesn't quite work. So you have to actually, if you have addition going on inside the absolute value, you have to do that first. Then you do the action of taking the absolute value. So in blue here, I've got this absolute value of -2 + 1. You would first do -2 + 1, which is -1. And that's still inside the absolute value symbols. Then you do the absolute value, making it positive after you've combined those. And then that would give you a +1 as your answer. So that's just kind of a side note there that yes, it makes things inside positive, but you have to make sure it's just one number inside there to use that rule. So you don't use that rule until you've got it down to one number inside the symbol. So just kind of a side note there. That's also something that people they want to make like the -2 + 1. They want to make all of them negative and have 2 + 1, but that would be incorrect. You got to get it down to one number first, then absolute value. So we did the top. Oh, that confused you. Okay, so let's say you have a problem. I'll do a slightly different number here. 3 minus 5. So let's say you have more than one thing inside an absolute value. And this could happen if you want to know the difference of, let's say we'll do the miles thing again. So let's say I've got some person at the mile marker 3, another person at mile marker 5, and I want to know what is the difference between those. Like what is the distance between those two people in miles? And I just have their location 3 and 5 as just these numbers. To find the distance between them, you can do 3 minus 5, to find because you're looking for how far away are those things from each other. Now we know if there's two people, one at 3, one at 5, the distance is 2. And you could do 5 minus 3, but you could also do 3 minus 5 to get the distance, because you're just looking at what is the difference between these two, and you can go either one as your starting point. If they're in a line north-south, you could say, okay, I'm going to go from north to south, or south to north. Like you can have a different starting point, and that would change how the order of your subtraction to get the distance. So when you're writing that in your absolute value, you need to do your subtraction first. So 3 minus 5 is negative 2. But the absolute value is giving us the distance, because we want the distance between these two people, so we want the positive. And so that answer would be 2. Now, the wrong way to do it, and I'm putting this in red because it's wrong, is I will see people say we have the absolute value of 3 minus 5, and anything that has a minus or a negative sign, they will turn to a positive. And they will say, okay, this is the same thing as 3 plus 5, and they'll do it that way. But that gives you the number 8, which is wrong, because the distance between two people, if one is at mile marker 2 and one is at mile marker 5, the distance between those is not 8. The distance is 2. So you have to simplify inside to get the absolute value to one number before you take the absolute value. Because the rule for the absolute value is that you have a single number inside there. So if you have more than one thing inside there, you have to do your math to get that to one number first. So another example would be -1 plus -6 inside absolute values. So I have more than one number inside these absolute values. So I need to add those together first. I need to do what it says, -1 plus -6. So I have to do that first because I don't have one number inside there. So -1 plus -6 is a -7. So now I have a -7 inside my absolute values. Now I can take the absolute value and it will turn that -7 into a +7. So your correct answer here is 7. So I start at -1. If we think of this on a number line, I've got -1. When you're adding a -6, this is saying, okay, I'm going to the left 6 places because negatives are always to the left. So I go 1, 2, 3, 4, 5, 6. So that's at -2, -3, -4, -5, -6. And we end up here at -7. Yes, and you're going sort of toward -6, but the adding a negative, negatives are going to the left. So you're just moving 6 to the left. That's what that -6 is. Now your final location you're here is at that you're at is -7. So now you're saying, okay, what is this distance between -7 and 0 now that I've done that operation, and that distance is 7. So if you're getting confused with the whole negatives positive thing and like adding and subtracting, negatives generally are, if you're adding a negative, you're going to the left. And subtraction means you're going to the left. But negatives also mean doing the opposite. So if you're subtracting a negative, if you have two negatives in a row, they cancel each other out and you're going to the right. So that's how you can visualize it on a number line. As generally negatives go to the left unless there's two of them in a row, and then they go to the right because they kind of flip-flop. Okay, cool. There are other questions on this that I just, what happens when you have more than one thing inside the absolute values? Okay, so if we look back here, so again, we had a little detour. My fault, I did the detour. So we're looking at whether these things are true or false. And so now we're on the second row here. So bottom left, we have -6 less than absolute value of -6. So the left, we don't have an absolute value symbol, so that stays as -6. On the right, we have the absolute value of -6, so that makes that positive. So that will give us a +6. So now we're saying we have -6 less than 6. Is -6 less than 6? That is true. -6 is smaller than 6. It's left on the number line. Left is smaller, is less than. So this is a true statement. The next one we have is the absolute value of -8 is greater than or equal to the absolute value of 8. So absolute value -8 becomes a +8. The absolute value of 8 also is a +8. So we've got 8 greater than or equal to 8. So the way this symbol works is that first you say is 8 greater than 8, and that is not true. 8 is not bigger than 8, but it's an or is 8 equal to 8? So that is true. 8 is equal to 8. So because that part is true, this whole statement is true. So it's either one or the other when you have a symbol that combines them both. Next one, we have the absolute value of -2 is less than or equal to the absolute value of 2. So the absolute value of -2 is a +2. And then we have less than or equal to, and then the absolute value of 2 is also a +2. So when we read this, we have is 2 less than 2? That is not true. But is 2 equal to 2? That is true because that symbol is less than or equal to. So because these are equal, this is a true statement. Then this last one here. So we've got this negative, then an absolute value of -21. So that absolute value of -21 becomes a +21, but then we have a negative in front because there was a negative in front of the absolute values. So that gives us a -21. Then we have a greater than, and then the absolute value of 11 is 11. So we are asking ourselves, is -21 greater than 11? And that's false. So -21 is smaller than 11. So this is a false statement. It's not greater, it's smaller, it's less than. So that whole thing is false. Yes. So a negative number is always less than a positive number. So There is not a negative number that is ever going to be larger than a positive. Just by definition, the negatives are always less than positive. So because 11 is positive and negative 21 is negative, the negative is smaller than 11. So that's why this is false, because it's not greater than, it's less than. So if you're struggling with your negatives and positives, looking at a number line can really help. And if the number is to the left of another number, it's smaller than that number. If it's to the right of a number, then it is larger than that number. Okay, so this was all I had planned on this concept of the absolute value. It's a simple concept. It's just you need kind of practice to kind of get used to the rules, what the symbol means, and you'll get that practice when you do the homework. So do you guys have any questions on anything about the course that I could perhaps answer at this time? Because I know first few days of class, usually there are questions about what do I do, things about that. So do you guys have any questions on that? Okay, well, I'm not seeing any questions there either. If you do have questions, you can just send me an email or ask the instructor. Just kind of as a reminder, get extra credit if you post in the discussions by tomorrow. So Friday. So if you want those 5 points extra credit, that is, a good thing to do. There are tons of things in the class for resources. On the left side, underneath the link to discussions, there is a link called videos, and I also have it linked in the weekly content. And so those are all videos that I have made from previous classes where I did live sessions like this. And so if you, like to watch videos as a learning tool, I would go look there and see if there are particular topics that you're like, oh, I don't understand this topic. I need to watch this video. Like I have a video on adding, subtracting things with negatives. I've got a video on just multiplying and dividing with negatives. So I encourage you to watch those videos and take notes. We've got a link to tutoring near at the bottom of the list. I think it just says connect now to a tutor. That's completely free for you. So they are available 24/7. So if doesn't matter if it's 1 a.m. and you're doing your math, there will be somebody there that can help you out. So that's a great resource. These live sessions I do 1 a week. They're likely to still be at the same time every Thursday, but I am waiting for more people to fill out that survey that I sent out with what times people are available, so I can try to pick a time where most people are available. So I want to make it so as many people can attend as possible. So I may change the time, but it usually ends up being the same time that I did in week 1. So it's probably going to be every Thursday at 7 p.m. Central. But we'll see. I'll send communications out. Always make sure you're reading the announcements. I have tons of helpful things in the announcements. So, that's if you have questions, looking at your announcements is the first thing to do because I may have already answered your question. And I think that's about it. As long as you turn in all of the work, which means doing the homework in Connect Math, taking your quiz in Connect Math, and then you have to submit to Blackboard a screenshot of your Connect Math grade book with the homework scores so that we can put that grade in the grade book because it doesn't directly translate into Blackboard. And Blackboard, you don't want to try to do math in Blackboard. It just doesn't like doing that. And then your quiz work, after you take the quiz, you're doing your stuff on paper as you're working through the quiz. You need to turn that in through Blackboard. So you can just take your phone and take a picture of your pages of the quiz and then upload it to Blackboard. There's a separate assignment. It will say quiz work and you upload your work there. And as long as you do all that, you do the discussions, you can pass the class. Like there's no reason to be afraid. you're going to do just fine. We're doing like week 1 is just about arithmetic. Week 2, we introduce variables and a little bit of solving. Week 3, then you're solving. Like for this course is definitely going to walk you through at a slower pace. So that way you can, you can get everything. And then if you do have to take college algebra, you'll have a better foundation in order to do that. Yes, I recommend that you wait to take the quiz until like the end of the week. I would not take the quiz first. Just, make sure you want to have time to study, to practice. Math is something that you learn best from practicing and doing some math every day, even if it's only half an hour in math. If you do it daily, that helps keep it in your head. So I usually recommend take the quiz Monday or Tuesday, don't take it right away. And then dyslexia, is it normal? Will it go away? So there's actually a special term if you kind of mix up numbers called dyscalculia. And I will actually do that. So at Alive, I may say one number and write down a different number. Sometimes I'll see a 9 and write a 6 or something like that. So I actually kind of have that. And it's usually, if that's something you have, it's something that you've always had. And the best way is just to be aware. So that way you're double checking everything. Like, it might be a little slower for me to do math because when I write something, I look back at what I wrote to make sure I wrote the right thing. I have to double check. Did I multiply those out right? Did I write the correct number I meant to write? Sometimes I rely on you guys to say you wrote the wrong number or you said the wrong number there. And I'm like, oh, thank you. So it's not necessarily that something that goes away, but it's completely normal. And it does not mean that you can't do math. I mean, I do it all the time, and I'm teaching math, and I got a graduate degree in math. So it's just some people do that and some people don't. Sometimes I'm more prone to doing that when I've been doing math for longer periods of time. So, if you find that you're making mistakes like that, take breaks. Don't spend so much doing the math at once, and that can kind of help that. And then just being aware and double checking everything that you write down can really help with that. Difference between PEDMAS and BODMAS. Oh, that is a great question. So they're the same thing. So in the US, we use P for parentheses. There are other countries, I know the UK does this, possibly Canada, that use B for brackets. So parentheses are the curved things. Brackets are the square things. That's what we call the square ones. They're both on your keyboard, but they mean the same thing in math regarding the order of operations. There are parts of math that we'll get to in week 7 where the parentheses and the bracket mean different things, but those are not in terms of the order of operations. That's in terms of graphing. So it's like a different situation for those symbols. But when you're talking about the order of operations, the P and the B mean the same thing. If you've got a mix of parentheses and brackets, sometimes you see both of those, you always work inside out. And then we've got E for exponent. I forget what the O stands for, but it basically is the same thing as exponent. They just use a different word for that. And then like we do PEMDAS with multiplication first and then division. Other countries will do the D first in their acronym and then multiplication. And those are both correct because the rule with multiplication and division is that you do whichever comes first when you read it left to right. So if you're looking at your math and you have a division symbol before the multiplication symbol, the division will come first. If you have a multiplication symbol before division, multiplication comes first. So multiplication and division are done left to right, whichever comes first, which is why doing PEMDAS versus PEDMAS, the D and the M, it doesn't matter which order those letters are because it's read left to right. And then addition and subtraction is the same thing. If subtraction happens first when you go left to right, then you do that first. Addition is not always first. It's just whichever out of those two, whichever comes first when you go left to right. So, depending on where you learned your order of operations, you may have learned different acronyms, but they're the exact same thing. They just may use different words or different orders for those two that can be done in either order, but it means the same exact thing. Yeah, and PEMDAS and PEDMAS are exact same thing. We just have those multiplication division reversed just because it really doesn't matter. You just always do whichever comes first, left to right. So Americans just always do PEMDAS. So that was how I learned it. But if you learned it a different way, it doesn't matter. You can use that. It means the same thing. Yeah, there's actually, man, I think that you could probably even look on the internet, PEMDAS versus BODMAS and all that kind of stuff. I know on Facebook, people love to give math problems and then there's an argument on what the right answer is. And those drive me nuts because I'm like, people are so convinced that their answer is right, but they're actually doing the order of operations wrong. So all those say to me is that you guys don't remember your math. Well, if there's no other questions, then we can call it a night. You guys can go back to, whatever you're doing. If you were doing math, I would take a break because you just sat through some math. So don't go back to math. Take a nice little break before you do more math. Maybe switch to another class if you're doing another class, or, maybe depending on what time zone you're in, you're just like, okay, it's time to kind of relax before bed. But you guys will get more communications from me. Yeah, good call. Yep. Don't do more math. Take a break. Make sure you're checking your Grantham email because usually I send out announcements Wednesdays and Fridays. And then usually the first week there's more announcements that I send out just because there's so much important information. So, make sure you're checking your emails. I may, be reaching out if I notice that you're missing something, throughout the term, things like that. So just stay on top of that. And you guys will all be fine. I'm not worried about anybody in this class, really. You guys will find that math is not as scary as you may be thinking. It truly is not as bad as it may seem. So, and I say this with confidence because that's what students have told me after taking this class. So I'm like, that's what your classmates have said, not just me. So it's not so bad. So I will let you guys go. Hopefully I'll see you all at my next live. Again, I'll email out when that will be. You'll get an email tomorrow with this recording. And you guys have a great night, great weekend because tomorrow's Friday. We got the Super Bowl coming up. There's Valentine's Day. It's probably going to be a busy weekend for you guys. So good luck finding time to do stuff. But, you can find that time. So, all right. Bye, everybody. Take care.